All right, chemistry. So you just finished taking your practice quiz, and I'm going to go over the answers, and hopefully I'll address any potential questions that you may have along the way. So, the first learning target, you are asked to identify the number of significant figures that are found in the number itself. So, in the case of the first one, 8,024, there is no decimal. So I'm going to draw a line coming in from the left, coming in from the right to the left. And then I'm going to count 1, 2, 3, 4. So this one has 4 sig figs. I'm going to go down. So 43.092. There is a decimal, so I'm going to come in from the right and count everything after. 1, 2, 3, 4, 5. So that one has 5 sig figs. 9.230 times 10 to the third. There's a decimal, so I'm going to come in from going toward the right, and 1, 2, 3, 4. This one has 4 sig figs, and because it's in scientific notation, doesn't actually change anything other than the fact that you're really looking at this number in the scientific notation there to identify how many sig figs it is. So that's really all that we're doing there. And then for the last one, there is a decimal, 0.00892. I'm going to draw a line going through all those zeros until I get to the first non-zero digit, and 1, 2, 3. So this one has 3 sig figs, like so. I guess the big thing to remember is that if there's a decimal, draw a line or draw an arrow to the right. And if there's no decimal, draw an arrow coming in from going to the left, and then count once you get to your non-zero digits. The next learning target that we're going to go through here is applying significant figure rules for performing different mathematical calculations. So the rules are pretty simple. Multiply and divide is your answer is based on number of sig figs. Add or subtract, your answer is based on number of decimal places, or decimal places past the decimal. So in the case of the first one, we are multiplying, so I'm going to be focusing on the multiplication division rule. And I take 2.93 times 9.220, and my calculator gives me an answer of 27.0146. So that's my calculator answer, and I'm going to round this to have the appropriate number of sig figs. So the first thing I'm going to do is going to go back and address or count the number of actual sig figs. So 2.93, So I'm going to draw my arrow because there's a decimal coming in here and count, and there's 1, 2, 3, so 3 sig figs. And then there's the 9.220. There's also a decimal there. So 1, 2, 3, 4. So 4 sig figs. So what I'm going to do is I'm going to go ahead and figure out the number of sig figs in my answer. And in this case, it has to be the fewest number of sig figs in the problem, which in this case is 3. So I'm going to draw my arrow and count 1, 2, 3. Draw a line, and I see that that 1 cannot round up that 0. So my answer is going to be 27.0. That's the number of significant figures. Now, in this case, we had the unit of meters times meters, which is going to equal meters squared. So my final answer is going to be 27.0 meters squared. On the quiz itself, we are going to be assessing your answer with the appropriate number of sig figs and the appropriate unit. So make sure that you're keeping track of that. In the case of B, we are adding. So our final answer is going to be based on number of decimal places. And when we plug this one into the calculator, we get something like 100.473. And because we're adding, we're not looking at significant figures, we're looking at decimal places. So I'm going to count there's 1, 2, 3. So there's 3 decimal places here. And there's 1, 2. So there's 2 decimal places here. So I'm going to have to round my answer to have 2 decimal places. So what I'm going to do is I'm going to count 1, 2, draw a line, and I see that 3 cannot round the 7 up. So my final answer here is going to be 100.47. And as a result of being 100.47, that's good, but now we need to assess our unit. And in this case, it's just kiloliters plus kiloliters. And when you add units, they stay the same. So that means that my final unit this time is going to be kiloliters, and it looks like that. The trick that I also showed in class was that if you took your numbers and stacked them, so let's see, 99.233 plus 1.24, and then if you just drew a line after the fewest number of decimal places, that helped at least me to decide where to round. So this would have been 100.47, and then that line chops off that 3, and then I know I rounded right. So that's the other trick that I generally use. The next one is multiplication and division, because we're dividing. So I took my 986 divided by 233.9, and the calculator answer that I got was 4.403751,675. And again, because we are using significant multiplication and division here, the final answer is going to be based on significant figures. And so there's no decimal point here for the 986. So I'm going to come in and draw an arrow pointing to the left, and I count 1, 2, 3. And so there's 3 sig figs there. There is a decimal in 223.9. So I'm going to draw an arrow going to the right and count 1, 2, 3, 4. So there's 4 sig figs there. So it's based on fewest number of significant figures. So I'm going to go ahead and count sig figs, drawing my line and count, because there's a decimal, 1, 2, 3, and I draw that line right there. And so in this instance, the 3 cannot round the 4 up or the 0 up. So my actual numerical answer is going to be 4.40. Now in this instance, we are going to take the unit, which is grams, and it's going to be divided by liters in the math problem, which I should probably rewrite a little bit differently. So it's grams divided by liters, which really means grams over liters. So my unit itself this time is going to be grams over liters, like so. All right, so that's how we apply significant figures to problems. And going forward, we are going to be assessing or expecting you to record all of your answers with the appropriate number of significant figures in every math problem that you do. Speaking of math, we're going to do density calculations next. So in this problem here, the first question says, what is the mass of a liquid that has a volume of 27.7 milliliters and a density of 1.25 grams per milliliter? And just like I have been doing in the past, I'm going to go ahead and identify my variables. So I see that I have a density, there's a mass, and then there's the volume. So in this problem, it says, what is the mass of a liquid that has a volume of 27.7 milliliters and a density of 1.25 grams per milliliter? So we're solving for mass. And I'm going to go ahead and do my first step, which is, I'm sorry if you can hear my cat whining in the background, is I'm going to identify my formula. So that's density is equal to mass over volume. And then I'm going to do my substitution. So in this problem here, my substitution would be the 1.25 grams per milliliter. And the mass is something that we're solving for. And the volume is 27.7 milliliters. Now we need to get our mass by itself. So we're going to multiply both sides by 27.7. And as I've always done in the past, I usually show all that work just so that everybody is aware of where I'm getting my numbers from. So it's going to be 27.7 milliliters times 1.25 grams per milliliter with a mass, and the 27.7 milliliters times 27.7 milliliters. Now, again, all I'm doing is I'm showing the work, and I realize that many of you can do part of this in your head, which is totally fine. I just want to make sure that we see our work all the way through for those of you that are just like, where do you get those numbers from? So now I'm going to take my 27.7 milliliters times the 1.25 grams per milliliter, and that leaves me set up solving for mass. So when I plug that into the calculator gives me an answer of 34.625. Now, again, we have to go back and assess significant figures. So when we do that, because there's a decimal in the density, I'm going to draw an arrow pointing to the right, and I count 1, 2, 3, and I see that there's 3 sig figs. For the volume, there's also a decimal, so I'm going to draw an arrow pointing to the right and count 1, 2, 3, and there's, I don't know what number that is, 3 sig figs. So my answer needs to have 3 sig figs. So I'm going to look at my number from the calculator, and I see there's a decimal, and I'm going to draw an arrow coming in from the right, and 1, 2, 3, and I'm going to draw that line, and that 2 does not round the 6 up. So in this case, my final answer numerically is going to be 34.6. Now, masses in this case are going to be in grams, so I'm going to have the correct unit like this. And just like we talked about earlier last week, how these problems are going to be assessed is you are going to get 1 point for showing your formula. You're going to get 1 point for substitution and 1 point for your answer with the correct number of significant figures and the correct unit. So this will probably be pretty close to a 3-point problem. And that's what we're looking for you to be doing there. Does that mean that you don't have to show the work in the middle? Technically not. And if you can do this without showing the work in the middle, that's great. But like I said, I'm going to always show the work going forward. Next one says, what is the density of a substance with a mass of 125 grams and a volume of 38.5 centimeters? So I'm going to identify my variables. So density, mass, and volume. So the problem is asking me to calculate the density when I know that the mass is 125 grams and I know that the volume is 38.5 centimeters cubed. So like before, I'm going to go ahead and write my formula. So density is equal to mass over volume. I'm going to go and do my substitution. So density is equal to 125 grams over the 38.5 centimeters cubed. And then when I plug that into the calculator, my calculator is going to give me a value of, it's 3.246753247. So we have to go ahead and assess significant figures. And in the 125, there's actually not a decimal. So I'm going to come in, that's sketchy. So I'm going to come in from with an arrow pointing to the left and count 1, 2, 3. So 125 has 3 sig figs. There is a decimal for 38.5. So I'm going to draw an arrow pointing to the right. And there's also 3 sig figs. And so I'm going to draw an arrow to the right here because there's a decimal, and I'm going to count 1, 2, 3, draw my line, and see that that 6 can indeed round that 4 up. So my final answer here is going to be 3.25. Now my unit is going to be grams over centimeters cubed. So this is going to be my final answer here. And again, we're going to show the work, or we're going to substitute, or I'm sorry, we're going to show the formula. That's 1 point, substitute, show the other point, that's the other point, and answer with the appropriate number of sig figs and correct unit, another point. So that's density. All right. The next one is we are going to use our graph here in an effort to determine what the density or what the mass or volume is. And so just to kind of go back and review, our volume happens to be on the independent variable. Our mass happens to be on the dependent variable. And this one is asking me to do a little bit of reading of the graph. So it says, a student produced a graph below when they measured the mass and volume of an unknown substance in the lab. What would you expect the mass of the of 45 cubic centimeter object to be? So in this case, we are trying to figure out what the mass is. So I'm going to use my highlighter, and I'm going to highlight 45, going to go up, and I'm going to go over. And what I'm actually seeing is that each of the increments on the graph go by 2. So it's like 2, 4. So it's like 2, 4, 6, 8, 10. So that means that it looks like the actual intersection here is just under 2, under that 2 mark, just under. So I'm going to say that this is probably somewhere around 41 to 42. 41 to about 42, let's say, grams. So somewhere in that ballpark is an answer that we'd probably accept, and this will probably be worth 1 point for the correct answer and 1 point, or 1 point for the correct answer with the appropriate unit. So make sure that you are using your units there. The next one is asking me to compare density, using density and compare it to 2 different objects. So we have a student here who finds a piece of copper and 1 piece of steel at their chemistry lab bench. They know that the piece of copper has a volume of exactly 1 cubic centimeter. So their question is, would the piece of steel need to be larger than 1 cubic centimeter, smaller than 1 cubic centimeter, or equal to 1 cubic centimeter to make it balance? So remember, if we want this to balance, the number of grams has to be the same. So conceptually, I think that some of us could probably reason out pretty quickly what the answer is going to be, but I'm going to go ahead and I'm just going to kind of do a little bit of math to support my answer right away. So in this instance, things that I know is that density is equal to mass over volume, right? And I happen to know that the density of copper is 8.5 grams per centimeter cubed. And I happen to know that the volume of this particular piece of copper in question is simply 1 centimeter cubed. So if I'm trying to figure out what mass I would need of steel, I need to figure out the mass of copper. So like we did before, we're going to solve for mass by multiplying both sides by 1 cubic centimeter. And we're going to find out that the mass here is going to be something like 8.5 grams is equal to the mass. And actually, so technically sig figs in this case would be that there's 1 cubic centimeter and the density is 9.5. Or 8.5. So really we might round this to 9 maybe. So we're looking at 9 grams. So now that means that I need to have 9 grams in my copper, and I need to figure out what the volume is going to actually be. So we're going to go back and do the same process. Density is equal to mass over volume. We know that the density is 7.8 grams per centimeter cubed. We know that the mass that we want is going to be like 9 grams. Oops, I should change that color. Is going to be like 9 grams. And the volume is what we need to figure out here. So we're going to multiply both sides by volume. So that gives me final, which is, or a final setup, which is volume is equal to 7.8 grams per cubic centimeter, equal to 9 grams. So I'm going to divide both sides by 7.8. And apparently I did not finish this problem in my pre-work. So let's see, 9 divided by 7.8 gives me, let's see, a volume that's equal to, let's say, 1.15. Yeah. So let's see. So 1.15 would tell me that if we're really, really looking at our values here conceptually, and I know that we should round this to have like 1 sig fig, so it's going to be 1. But in reality, what we're looking at here is the fact that the volume is going to be bigger. If the volume of the steel density has to be bigger. So I'm going to say that it has to be the volume of steel has to be larger than 1 centimeter cubed. So that's going to be probably one point. The other point is, how do we know? So we've talked about this in the fact that the ratio of mass to volume is going to be bigger or smaller. So in this instance, the ratio of mass to volume of steel is going to be a larger value or a larger ratio than or a smaller ratio, meaning that the volume has to be bigger. So what I'm getting at here is that the volume of the steel has to be larger because the ratio of mass to volume needs to reflect the difference in density. And what I'm really trying to get at here is that when an object has a smaller density, it's going to need more volume to get that same mass. And when an object has a bigger density, it's going to need less volume to get that same mass. So I guess I'll try to write that also. So when an object has a smaller density, it is going to need a larger volume to get the same mass. So that's probably the best way to describe that. Or you could just do the math. I mean, in reality, you could just simply do the math and show us that, and that, in my head, would basically support your answer. The next question is asking if the object in question would sink or float. And in this case, we have the steel, we're looking at the steel sample, and we know that the steel sample has a density of 7.8 grams per centimeter cubed, and water has a density of 1.0 grams per, in this case, milliliter. But really, in reality, the question is, will it sink or float? And the answer in this case is steel would sink. And why? The density is greater, but really, in reality, we're looking at the density, or the ratio of mass to volume is greater in the steel compared to the water. So we're really looking for some type of explanation in that regard. And then the last question on here, it says calculate the volume in cubic centimeters of copper needed to balance 84 cubic centimeters of steel. So we're looking to calculate the volume, and we have to remember that when we're talking about something that's balancing, right? So we've got our teeter-totter here, we got our fulcrum, we have an object there and an object there. And so if we have 84 cubic centimeters, let me put that on the bottom. So if we have 84 centimeters cubed for my steel, what we're really looking for is the amount of mass that will make the copper balance. So that's the first step. So in this case, my first step is to find the mass of the steel. So I'm going to start with density is equal to mass over volume. And I know that the density of my steel is 7.8 grams per centimeter cubed. And I want to solve for my mass. So in this case, I'm going to take my volume, which is 84 centimeters cubed, and solve for the mass. I'm going to multiply both sides by the 84. So I get 84 centimeters cubed times 7.8 grams per centimeter cubed will be equal to the mass. And when I multiply that out, let's see, we get something like 84 times 7.8 gets me 655. So 655.2 grams for my mass. So I'm going to need 655.2 grams essentially. So the next part of this is I'm going to solve for volume of copper. So that's going to look something like this. So in order for these to balance, I need to have 655 grams basically. So I'm going to start with density is equal to mass over volume. Mass over volume. And then I know that the density of copper is 8.5 grams per centimeter cubed. I know the mass that I need is 655.2 grams. And I'm going to solve for my volume. So I'll multiply volume to both sides. And my problem will have like 8.5 grams per centimeter cubed. And that's going to equal the mass, which is 655.2 grams. I'm going to divide both sides by the 8.5. So that's going to give me my volume, which will equal the 655.2 grams over the 8.5 grams per centimeter cubed. And when I solve that out, 655.2 divided by 8.5, I get a volume of 77.0823 and in this case, sig figs tell me that I basically started with 2 sig figs, so I needed to end with 2 sig figs in all cases. So my volume here will be like 77, and it'll be centimeters cubed. So those are your steps that a person would need to go to make sure that you can balance something when you know a density, but you don't know it's the object's mass. The last thing that you're going to be doing on this assessment, you will be basically doing the same series of calculations that you did for your lab. So you'll be given a data table with mass, length, width, and height that will have the volume, the measurements in it. You'll be calculating the volume using the appropriate number of significant figures and units. You'll calculate the density using the appropriate number of significant figures and units, and you will be then using your calculated densities to go ahead and determine whether or not, or which block or which substance is which substance. So we're going to have some time to kind of talk about this a little bit on Monday, hopefully, and then you will have time in class on Tuesday to take this quiz. So hopefully this video helped a little bit, and hopefully you have a good afternoon. Bye now.